It's perhaps the most extraordinary story in modern medicine. A 20-year research project, an international team of scientists, and a woman who would not let go. Her quest to cure a deadly disease passed on from parent to child through their genes. It's a goal that brought her to the shores of an inland South American sea and face to face with the terrible torment suffered by thousands. But for Nancy Wexler, this is more than a mission of mercy. She too may have the disease, and time may be running out. Wexler is a pioneer. She's part of a very special group of scientists. They travel the world unlocking the wonders and mysteries of DNA, exploring the frontiers of genetic science, unraveling the secrets of life itself. At first glance, it looks like a typical scene in Southern America, the barrios baking in the noonday sun. But nothing could be further from the truth. For this is a village of the damned.
There's involuntary movements that gets in their way of normal life. Most of the time they do know what's happening, and that's what makes it so terrible for them too, because they cannot control it.
By the shores of Lake Maracaibo in Venezuela stands the town of Barranquitas. It's a poor yet picturesque spot, about 300 miles west of the country's capital, Caracas. Each day, the boats go out to fish the lake's turbulent and sometimes dangerous waters. The way of life here hasn't changed for hundreds of years, and nor, tragically, has the way of death. For Barranquitas holds a terrible secret. The people here suffer a rare disease. It's hereditary, passed on from parents to children by the genes they carry. There is no cure, and death is inevitable.
Once you go to the barrio and you go to those towns, you can't just ignore that happened, because it's just such a terrible reality. I could imagine how could you live thinking that someday that what you see every day in this part of your life can happen to you too.
The killer has a name. The locals call it El Mal de San Vito, the sickness of St. Vitus. We know it better as Huntington's disease. Gene hunter Nancy Wexler first came to Barranquitas in 1979. What she found was the greatest Huntington's hotspot on the planet.
Probably, at least half the population is either affected by or at risk for Huntington's disease, and maybe more. The majority are under the age of 40. About 14,000 are still living. There's probably around 1,000 or more who have either died of Huntington's or are currently symptomatic.
Hola, ¿cómo estás tú?
They call her the Blonde Angel. For over 20 years, Wexler has regularly returned to Barranquitas. At first with a handful of students and a heart full of hopes. More recently, with a group of some of the world's leading genetic scientists. For local people, Wexler's annual visit has become an institution and a lifeline.
They believed that we genuinely cared about them. We genuinely wanted to find the cure. And they could trust us because we were family. We came back every year. We didn't, sort of like skip out on them.
But Wexler's interest in the disease was more than scientific. It was also personal. For Nancy Wexler is no stranger to Huntington's. In 1978, her own mother died of the disease. And that means for Wexler herself, time might be running out.
It's so random. I think that's the hardest thing about Huntington's or any genetic disease, is that there's nothing you can do to control that. And it's something that, and you always watch for it to say, well, is it coming? What's it going to look like? What's going to happen to me? And after my mother died, I went to the beach and I said, can I do this? It's emotionally hard a lot of times. And then I just thought about it a lot and I said, can I do anything other than this? I can't.
Wexler's lifelong mission to find the genetic trigger for Huntington's began with a look at the impact of the disease on the brain. Enter Dr. Ann Young, a brain specialist who has become closely connected with the Venezuela project. For over 2 decades, she has studied the damage done by Huntington's to the human brain.
This is the human brain. This area that has 2 hemispheres. This would be the front of the head, and back here, the back of the head, with the eyes and the nose here.
It's chemistry that causes Huntington's, an imbalance in the chemistry of the brain. But what exactly goes on has baffled scientists for many years. They know what the disease does, but they don't know why.
The nerve cells in this area die in Huntington's probably more prominently than in any other region.
This is the part of the brain that suffers most from the chemical activity. It's the region that controls movement, the basal ganglia. As Huntington's begins its gruesome work, gritty deposits build up, cutting off the flow of information between brain cells. The cells in the basal ganglia begin to die, and sufferers lose control of their limbs. As the disease advances, the deadly deposits begin appearing in another part of the brain, the cortex. The cortex controls speech and memory. It is the personality center of the brain. Its deterioration is catastrophic. Wexler knew that Huntington's was a genetically dominant disorder. If one parent had it, each of their children had a 50% chance of developing the disease too. If both parents had it, then the odds went up to 75%. It was the arithmetic of death.
But the really traumatic part is that there's between 2,000 and 3,000 children who have a 1 in 2 chance of getting this disease. And that is going to be just a total, tsunami in the community because there's no way they can cope with it.
Wexler had one aim: find the genetic cause of so much misery. And to do it, she had to learn how the disease traveled between generations. So began a painstaking period of research. Wexler and her team became family historians, tracking down the connections of 10,000 people and mapping that against outbreaks of the disease.
When we first started out, we made a big family tree and we put little Polaroid pictures of people so we could know who's who. And we pasted the Polaroids on the family tree, and then we pasted up the family tree next to where the families were living. And we would say, go stand under your nearest relative.
Against this human data, they stacked genetic data. Wexler's team took skin biopsies and blood samples from the people they interviewed. The people of Barranquitas enthusiastically entered into the routine. In effect, they became their own gene hunters. It was a remarkable genetic research project.
So we started to say, we want to find a cure for Huntington's disease. You are the people who are the best people in the world that could have a chance of doing this.
Simply by observing the people of Barranquitas, Wexler's team learned a lot about how the disease operates.
So we put together an exam that focuses on first eye movements, just looking from one, target to another. We had these bandanas with striped lines that we would bring in front of their eyes and back, and that makes you, just like when you're looking out the window on a train and trees are going by, you can feel your eyes going toot, 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 toot. It's the same thing that we induce, and that tends to slow down or become abnormal early in Huntington's disease. Then we have them hold their hands out. We look at what we call fine motor movements, which are just tapping your fingers and going like this. We used to call these arepas for the people. Let's do arepas, because arepas are the little corn cakes that they use, and that's the way they would pat them back and forth.
Other neurological tests involved a pinboard game or moving shapes around on a computer. Because the disease is a so-called dominant disorder, and because of the way it moved within families, the team determined the cause lay with just one mutant gene.
It's almost inconceivable to think that your entire destiny can be determined by the most absolutely minuscule change in one teeny tiny gene that's like a billionth of all of your genes.
But finding that gene was not going to be easy. Wexler needed help, and this hospital offered it, the Massachusetts General in Boston. It was to a lab like this in the Massachusetts General Hospital that gene hunter Nancy Wexler brought her DNA samples from Barranquitas. On the discoveries made in this room could rest the fate of many thousands of suffering people, not just in Barranquitas, but around the world. The scale of the hunt was both microscopic and monumental, for the genetic cause of Huntington's disease lay hidden somewhere in the trillions of tiny cells that make up the human body. Each human cell contains an entire genetic blueprint that defines how our bodies work. We inherit the blueprint from our mother and father, 23 pairs of chromosomes. Within each chromosome, thousands of genes, tiny chemical factories producing sugars and proteins in unique combinations. The Huntington's gene lay on just one chromosome.
If you took a single genome from everybody on the planet, you could fit all of them in one of my hairs. You could get the entire planet. I mean, we think that people, that China has had a lot of people. You can get a planet in here, because that's how thin DNA is. I mean, needles in the haystacks are just, the wrong metaphor. This is like looking for a piece of hay in a haystack.
Enter another key member of Wexler's team, molecular biologist David Hausman. Hausman had come up with an idea, an approach to tracking the Huntington gene that for the time was little short of revolutionary. Some people had said it could take 50 years to find the mutant gene. Others advised caution. Wait until better genetic mapping techniques come along, they said. But as it turned out, they were proven wrong.
People just didn't think this was going to work in a short time frame. And it did, and it had a tremendous impact, I think, on the scientific community to realize this could be done.
Hausman had realized that in tracking Huntington's, the genes themselves could offer signposts. Scientists call them markers, chemical patterns that repeat themselves along the chromosome and define the boundaries of each gene. On only their 12th attempt in 1983, Hausman's team found the marker they were looking for. It was at the top of chromosome 4. Hardly daring to believe their luck, they tested other samples from other families and found the same marker in the same place. Houseman had hit the jackpot.
It was just an amazing moment. The day that the mist suddenly cleared, and behind those mists, the gene emerged, and for the first time, we were face to face with it. And it was just that moment you turn the page and you go from, what's wrong? Now how do we fix it?
And in 1993, the HD gene itself was found. Slowly, the disease was being forced to give up its secrets. Here's how the Huntington's gene kills. Genes are tiny chemical factories, each tasked to produce thousands of unique combinations of proteins. Each protein is made up of 3 chemical bases. The brain deposits caused by the disease come from just one protein, now called Huntington. The protein's 3 constituent chemicals are each assigned a letter, C, A, G. We all have the protein. In trace amounts, it's harmless, but when the gene starts to make too much, CAG spells doom. For the people of Barranquitas, whose DNA had led to this breakthrough, the discovery of the gene offered some light in the years of darkness they had so far endured. For scientists could now devise a predictive test. Parents would at least know what chance they or their children had of developing symptoms. But for Nancy Wexler, that test created a terrible dilemma. Her mother had died of Huntington's. Now she could answer the question that had dogged her family for so many years.
We really had to struggle with this issue. Well, okay, do we want to know this? Do we want to open this Pandora's box? And I said, I'm really pretty happy, actually, doing what I'm doing. I love what I'm doing. I love trying to find a cure for Huntington's. I love the foundation. I love the research. I love going down to Venezuela. So I would stand to lose a huge amount more by finding out I had the gene than I would stand to gain in joy by finding out I was free of the gene. Now, and so for us, we said, okay, right now, let's put it on hold.
Taking the predictive test was the only thing that Wexler did put on hold. Fast forward 5 years to 1997. Nancy Wexler is on the road again, not this time to Venezuela, but to London. The reason? Developments in Britain have led to some remarkable discoveries. Discoveries that could end the nightmare of Huntington's for good.
Tuesday.
Here is the handiwork of the London team. Mice. They look ordinary enough, but these mice are special. Professor Gillian Bates, working at Guy's Hospital, found that she could clone the HD gene and transplant it into the mice. The mice developed an accelerated form of the disease. Symptoms that took years in humans, scientists could observe in the mice in a matter of months.
The mouse model that we developed here at Guy's has a very rapid progression. So in fact, we've managed to compact something like 40 years of the patient's life into about 3 months. So you can imagine that this allows us to do things very, very quickly. So actually, there's a huge number of research groups working with these mice now, and there's been a lot of major developments fairly recently.
The mice have caused a sensation. Through them may be found the cure for Huntington's. Not a cure exactly, but ways of delaying or reversing the symptoms. The first advance came courtesy of a simple, readily available protein supplement called creatine.
Creatine is just is a substance that you can buy in a drugstore, essentially. I mean, it's something that athletes take. It's used to boost their energy reserves, and we think it just gives cells more stamina, essentially.
When given to the mice, creatine helped their brain cells ward off the toxic effects of the deadly Huntington protein.
The most amazing thing was absolutely anything you can measure was delayed, which was really utterly unexpected. So the symptoms are delayed, and the mice live about 20% longer.
Creatine slowed down the onset of Huntington's in the mice by 17 days. It made a remarkable difference. Now, a team in the United States is looking at a second drug, an antibiotic called minocycline. This can be used to turn off the supply of Huntington protein to mice brains. The results are startling.
The first thing was the aggregates went away, and the second thing was that the mice got better, which was also amazing because it means that for the first time we might think that if you can treat Huntington's disease in the early stages, then you might actually even be able to reverse it, which is not something we'd even considered as being a possibility before this piece of work.
Through special mice, first bred in London, heart-rending scenes like this one may soon become a thing of the past, both in Barranquitas and in the world at large. Nancy Wexler has traveled a very long road. A gene hunt that has lasted over 20 years. During that time, she's made many friends and lost many more. And it's the thought of those friends that drives her on.
I've gotten to know so many people. I mean, the entire family in Venezuela, you know, all 16,000 people I feel is part of my close family. There's so much my blood and bones, and there just isn't any way in the whole wide world that I would change, turn my back, stop, because it's like a consuming passion.
For Wexler never forgets that without the help of a beleaguered community in Venezuela, hundreds of thousands of people worldwide would remain condemned to a life, at best, of uncertainty, at worst, of lingering and inescapable death. The world owes Nancy Wexler a great debt, but it owes the people of Barranquitas even more.
Coming up next, will 5 scientists survive outside the lab? Witness their struggle to endure harsh conditions using only the most basic tools. Rough Science, next on the Science Channel.